So, welcome back to our really nice HackerRang coding challenge, and we are still at data structure, we are still at linked list, we are still at insert a node at a head of a linked list, which is our next challenge. It should be really simple, I think. Because what we really need is a new head. And if we have a new head, we say new head data x new head next equals head return new head. That's simpler than adding it at the last position. Oh, always these challenges are so easy. So they're getting easier. They're not that easy, but they're getting easier. Okay, what's the task? Insert a node at a specific position in a linked list. Okay. Okay, position. I think they start with 0, right? Okay, sample input. We have a null. Head is null. Data 3 position 0. Okay, they start with 0, null, data 4 position. Okay, yes. Okay, at a specific position. Okay, we have a current position. It's 0. While current position smaller than position. Current position plus plus. Node current node equals head, and current node equals current node next. So then we are iterating through this list. So and now current position is head. Okay. Okay. Node current head equals head. Nah, I don't know. Node new node. Node new node. New node equals new node. Okay. Data. This is simple. This is straightforward. This is okay. New node next equals current rent node. Okay. This is straightforward. We need the predecessor to this one. This is not that simple. Current predecessor equals null, and current node, so, and current predecessor next equals new node. That's it. Return head. That's fine, but not for the first statement. Ah, okay. If current predecessor equals not equals null, then we do this one, because then we know we're not at the possession 0. Else return new node, because this is a new head. I don't know. I have so much luck. It could be white. Huh. Okay, that's fun. So easy. Delete a node. Oh god. Head position. Okay. Some special cases. because it's easier then. Return head next. Okay. Okay, but if it's greater, we still need to iterate through this list. Okay, node, current node equals head, node, thread node, predecessor node equals null, while current position, smaller position, current position is 0. We iterate with current position, and we iterate with thread node equals current node, and current node equals current node next. So now we are at the position, and we have to do something like thread node next equals current node next, and that's it. Return the head. We just overpoint the current one. Should I explain a little bit more? I don't think so. I think you get an idea of what I'm doing. Oh no, come on. What's wrong with the internet? Hopefully they get my deletion. Try it again. Delete a node, okay. Oh, we have some left. Linked list is really an easy data structure. So what a print in reserve. Oh, that's ho. It's something like print, but in the other way. It's not double linked, so you can't go to the last one and then to the first one. I could make a list. I could use a list, or I could use a linked. I don't want to use array or list or something like that here. I want to keep here in the linked list. So what I want to do is new list head, okay. Now new node. New list. It's new list. Or ref list. Reverse list. Reverse list. Data equals head data. While current next. Okay, if I have a next, say current equals current next. So we are at the next one. Then ref list yes, we need a new node. New node equals new node. New node data equals current data. So we are building a new list, and new node next equals the list, the head, and the new node becomes the head of the list. So, and then we're going from the front to the end, but we are adding always at the first position. And this means we should now have a list We can reuse current. We should now have a list that works pretty good. Oh, what if we have an empty list here? Empty lists are not working. I think it's dumping here. Ah. It's a special case. So current is the head of the ref list. Current not equals null. We print it out. System out print. I think we should print a line, right? Yes, we should print a whole line. Current data. Current equals current next, and that's it. Does it work? Does it work? I don't know. It's so many code. It's now a compilation error. New node. New node. Yes, the names are not good, but it's really 30 lines. It's not that. New node, new. It's not that big. It's not that big deal. Oh, it's always oh yeah. So if we ignore the exceptions or the compilation errors, it's always a one hit wonder, which is good. Okay, reserve a link. Oh no, come on, please don't do that. Please, can I see my submission from the last one? I can't. Submission accepted. Do I have it here? Yes, I still have it here. I just copy it. It's not that. So print in reverse and create a reverse list. It's the same task, really. We can skip that. Compilation error, return. Null. It's a little bit. Oh no, do not print. Ah, yeah, okay. 5 extra points, yeah, 120 points, and compare. Come on, we do this. We do this. We do this because I have a good day now. Today I have a good day, and we will do this. So we're going through the list synchronously. Current A equals current A next. So we're going through this list, and every element we will check. If current A data not equals current B data, return. Oh yeah, what do I have to return? Return 1 if they're okay. They're not identical. So, and what I do is I always return 1 because I think they are identical, and I'm searching for an error here. So, but this, if we come to this point, that mustn't mean they're identical, because it could be that current A not equals current B. There, one is null and the other is not, because now I'm comparing references. I think this is a special case. The length of the list differs. Can I see the test case if there's something like that? No, whatever. I would have checked it. Okay, what merge two sorted linked. Ah, okay, they are both sorted and I need to merge them. Okay. First of all, I need a new head. And I need a current A. It's really hard to just keep talking and thinking about the problem, but as long as the problem is not that complex, it's okay. So as long as we are not at the end of both lists, we continue. Okay. We make a little bit of distinction here. We say, okay, if current A equals null, then current B is not null. And then we know we can add it to the list, but at the end of the list. That is hard, because I have to add it. The head is not that important. Current and it's tail. Tail dot next equals current B. So and just move the tail. And it's the same here, but the tail shouldn't be unequal to null. Okay, I have to check it. If tail equals null, tail equals new node. Yes, I merged the two lists, but I use the pointers from these lists. Maybe that's not that. I modify this list. Do I have to keep this list as they were? Maybe. Maybe. I will do it. I will keep the lists as they were. This is a new node. And here I can make the distinction. If tail equals 0, can I intent here in any way? Okay. If tail equals 0, tail equals new node. Oh no, tail is new node. Head is new node. Otherwise, tail of next equals new node. If unequals 0, okay. Here I create a new list, and here I go, here I set the pointer from tail to the new node. And here I just have to say data equals current B data. Current B equals current B next. Current A data. Okay, and iterate. So, but these are very special cases if the other list is empty, or we are the current point of the list, and this is the end of the list. So no, both are unequal 0. Or current A data, smaller current B data. They are sorted, yes, in ascending order. No. Current B is smaller than A. So, if A is empty or B is smaller, use B, otherwise use A. We set the data, we point to it. The point of the new node is null because it's a tail. We set it to the tail. Tail is new node, tail next, new node. Yeah. So this is a little bit simpler. I don't know. We had so many luck. Maybe this time. It's still working. No compilation error. Oh god. Where do I have to add a bracket, or did I? Yeah, I missed the bracket. Because the else is missing. Error. Where? Okay. Open bracket, close bracket, open bracket, close bracket. Open bracket, close, open, close. Open, close. Open, close. Can't see the missing. Oh, missing return statement. Sorry. Missing return statement. This is easy. So now we can compile it and no. Oh, first time we missed it. Oh, I have to test my statement. Oh god, how? What's this for input? 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 12, 15, 1, 2, null. Ah, okay. Sorry. Sorry. Input mismatch. Don't know how to test this, but somewhere there is an error. But they say this is the input. I thought they have a parser for this. No, they don't. Okay. So let's have a look. So we have no tail, we have no head, and the output indicates that the nodes from both lists are merged into a single list. Okay. So return is the head of the merge. Do not print anything. Okay. So head and tail, current A, current B, head A, head B. Okay, and as long as we are not at the end, go through those two lists. So when do I have to use a current element in B? If the current element in A is empty, or B is smaller than A. Then I take it from B and I move B one further, same as here with A. Else if, no, it's just else. Sorry. Hopefully, no, this is not the error. This is not the error. Why? Why is this not the error? Okay, if tail is null, then I know I have a new list. I add head and tail. Else tail is new node, tail next, and I move the tail one further. might be the error. One time. Can I download it? Download. Expected output. Okay. 1, 2, 3, 4, 5, 6, 7, 12, 15. 1, 2. Okay. Input. One, two, three. Okay, this is the input. 3 test cases. I think this is count of test cases. This is the first list, the second list, first list, second list. First list, second list. Okay. Let's try this out. This is how it works. One test case. One, two, three, four, five, 7 is missing. 7 is missing, is the last one. The last one is missing. Why? They are both empty. One, two. Oh, sorry. 1. Okay, because list A, current A points to 1, this to 2. Okay, both are not. No, this is not the case. It's not this one. Ah, okay, I stopped to. What? Too early? Okay, now this is working. Null pointer exception. Merge lists. A null pointer. Where could be a null pointer? If a equals 0, then b is not null here. Oh my god. Where's the arrow? B next. Okay, but B is not null, so this could be null, but that's okay. Current A data. Next node data. Next node can't be null because I have a new node here. Still a null pointer exception. I mean, in my opinion, this is all implicitly correct, yes. This is the only thing where a null pointer exception could happen. Because here, Here a null pointer exception could happen. A is empty, B is not empty. Use B. What if A is not empty and B is empty and yes. A is empty, take B. Or B is not empty, and yes, this is it. This could be the case. Thought too fast. Yes, it looks good. Okay, this was a little bit harder, but we got it. This is the final? Yes, I think this is the final one. And for the final one, I will do a new episode. So leave a like, subscribe, or do whatever you want. Bye.